Sriram's idea, so it's so great. And Tom Dean also was one of the other people, so if he's, I don't see Tom here yet. Okay, so I think that this is one of their sponsors. They're going to have some books here that they're going to give out a little bit later on. And so today, this is just a general outline. So the first half of the class, we got pinned down pretty well. The second half, we may rearrange a little bit, and so there was, but you know, the main idea is that it's on distributed apps. So the first half is talking about classic Bitcoin things, and this is stuff that we know about, the distributed apps and other things. In the second half, the exact topics and the exact classes are we're doing it on the fly, just in time. So. Okay, so today I think Robert already went through the schedule a little bit. So I guess just you know, without further, yeah, I guess I don't know if I need to do that. That's kind of obvious. So yeah, I guess the point is we're kind of all volunteers, and we're trying to do we're doing. Hopefully it'll be a useful project. So our instructor for this introduction to the blockchain, specifically focusing on Bitcoin, is Ryan Smith, who is the CTO at Chain. And so without further ado, Ryan, please.
Thank you. Hello, good morning. Thanks for coming. 9 o'clock is kind of early, 9:15, whatever. Out of curiosity, how many of you know about Bitcoin? Raise your hand. Okay. Now, how many of you have sent or received Bitcoin? Raise your hand. Okay. Like through a wallet app on your phone, or what's the technique? Shout out. Coinbase. Electrum. All right. Armory. Does anybody have Armory installed on their computer?
I tried.
We tried, yeah. I think, yeah. Me too. It's kind of hard. Let me make sure I got my screen on here. Is it absolutely necessary that I use the microphone? Are we recording this, or can I just talk loudly?
More better, if you can.
Okay. I will use that. Oh wow, it just works. Cool. Right, so you saw the schedule up there, and there was like intro to the blockchain, and there was transactions, and P2P, and mining, and all of that. And so like, there's gonna be like a lot of deep dives through all these concepts. But today, in this lecture, this 1 hour lecture, we're gonna like cover everything. So if you're paying attention, you can just go to this lecture and then get out. No, I'm just kidding. You should come back for all of them, because like each little section has just a huge amount of depth to it. And I've been working with Bitcoin for I've been working with Bitcoin full time for almost a year now, like as my primary job, and I still learn every day. Like it is such. There's like even a great like Satoshi quote that was like, you know, like the world has never. I'm totally paraphrasing, but like the world has never seen this like type of technology before. Like this is totally new, and so like. It's very hard to grasp in general, because like you're dealing with like economics, and you're dealing with game theory, and you're dealing with cryptography, and like there's so many weird dimensions at play here that like it takes like you have to get your mind into kind of like a weird place to like kind of be effective at it. And I don't know, I'm sure there's a lot, like I'm not like the most talented like engineer or the smartest person in the room, like that's for sure. And so it took me a long time to kind of get to that level. And so some of you may like already be on that level, but also just keep in mind that, you know, like you just have to like keep at this for a long time. You have to like really wrap your head around it and really build stuff to make progress. So I don't know, that's one kind of caveat to the day. Oh yeah, also, do you guys like my t-shirt? I'm modeling a Chain t-shirt right now. So I have a whole bag of chain t-shirts up here. And so after the lecture, you guys can come grab chain t-shirts from me. I have all different sizes, women's sizes. I also have these cool stickers too. So just hang with me, and at the end you get a prize. Okay, and then is everybody like, are we software developers here? Is that what the, yeah? Like web developers? iPhone? Back-end stuff? Full stack developers, DevOps, we'll just say buzzwords, Ruby on Rails. Okay, cool. So I'm going to give like a couple examples like throughout the day with a little bit of code, and they'll be in JavaScript because JavaScript is really easy. It's like what do they say? You know, people who write JavaScript never like have learned JavaScript. I don't know how that works, but like you know, it just kind of happens. So we'll have some JavaScript examples. Yeah, so and just a quick note about like where I'm coming from. So I'm an engineer. Like I write code all day, every day. Before Chain, I worked at Heroku, and I was an engineer there. I was there for like 4 years, and so like my head's like really in like kind of back-end systems, database technology, stuff like that. So feel free to like hit me up with any questions like along those lines as well. Definitely happy to talk shop. So let's get started. The blockchain. This is it. This is the blockchain. So how many of you have seen this before? Is this a familiar thing? Yeah, some of you? Okay, great. So we can really take some time to introduce it here. So all like Bitcoin and the blockchain, like they're the same thing. Like you can't have one without the other. Like they were. And this is a super opinionated thing to say, but like this is my belief. So so basically what we have is like we have this data structure called a block. And it just happens to have its own binary encoding, but you can imagine like it's just a JSON thing or whatever. It's just like a piece of data called a block, and this data structure has references to other blocks, and you string them together and you have a blockchain. So you can see here in this example we have block 1, and it has a header, and it has the hash of the previous block header. Now there is this thing like the first block that was introduced in Bitcoin is called the Genesis block. And it obviously doesn't reference like a previous block because it's the first one. It was like the bootstrap. But all subsequent blocks contain a hash of the previous block header. And in the block header, you can see that there is a so this section right here is the block header, and then also in the block are all the transactions in the block. Okay, so like a block contains the transactions, but it also has like a special header. And so the transactions, like inside the block, the transactions are stored in a Merkle tree. And this is like, everybody's got their laptops open, so like there's like, I would suggest that like you wiki these terms. Like Merkle tree is a great one. Like that's like a fun thing to kind of poke around with and understand. But basically, this tree structure has this property where all the nodes in the tree, like their data is combined to produce like a unique root value. And so if you change anything in the tree, the root value is going to change. And so what we get here then is we have like in the block header, because there's a Merkle root in the block header, we basically have a cryptographic signature of all the transactions that are contained within the block. So if we take the hash of the block header, then we also, like, so if we change any of the transactions in the tree, that means the hash of the block header is going to change, right? So, so what that means then is that as we continue to like include the block headers, so like, because this is the hash of this block header, and this block header contains signatures of all these transactions, we know that if any of the transactions change in the blockchain, like that's going to upset the chain. Like all the links are they won't work out that way. So we kind of have this method of composing data together in such a way that if anything changes like further down the line, like if you run through all the signatures, if you try and change data at like block 1 or block 2, and then and like let's say today we're at block, I don't know, like 380,000 or something. if you were to go back in time and run all the verifications again, and if you change a transaction in block 1, like the system wouldn't work out. Like there would be discrepancies. And so we kind of have this nice property of like composing signatures so that we can always validate that the blockchain is in fact correct. Like the data has not been corrupted.
So, sorry. Would it be corrupted, or would it just mean that the blockchain got smaller because there's no, header, or there's no pointer to the next hash or next block, basically?
Well, specifically, like, so the question, well, I'm having a hard time paraphrasing that question, but I think I got you. I don't know, communication, how does it work? So basically what we're trying to protect against is like somebody, because, okay, so let's also take a step back here. This blockchain, this data structure, like this chain of blocks, this data is stored on every full node software that runs in the Bitcoin network. And we'll kind of touch on this more a little bit later, but there is like the Bitcoin network and anybody can participate in it, and there's a Bitcoin node software, and this software has all of this data. And just anecdotally, like today this data is about, I don't know, like 30 gigs or something, so it's a lot of data. But so what we're trying to, like this whole hashing business is trying to prevent like any one person with the software like trying to change transactions. So it's basically like, and it might not even be malicious. Like you could have like your blockchain data on disk on an EC2 instance, and your EC2 instance like has drive corruption, right? Like it's both malicious and also just like dealing with computers. So like we have this way of like knowing that, or of going back and cryptographically verifying that all of the data is what we thought it was. Does that answer your question?
It's okay. I'll ask you afterwards. I don't want to take too much time.
Oh, okay, cool. But feel free, like, let's actually pause here. And like, are there any other questions? Like, are you guys with me up until now?
Well, so it depends on the genesis block, right?
Yes.
So by knowing what block is the genesis block, that's how you can verify that the sequence is correct, right?
Yeah.
Right? So like in response to what he was asking, right? So
I think so.
If one of the blocks got corrupted, right, and you now no longer have a hash of the previous block, right?
Right.
If that block is not the genesis block, then you know you have a problem, right? But if it is a genesis block, then you know you have the full chain.
Yes, right? That is correct. Yeah, you can always look back at the, you should, yeah.
I guess my point was my local chain could be different if I decided to change transactions around. My local chain would be different than the real, like the official, I guess, however you define official chain, right? Because I changed some transaction locally that had an effect on the chain that I am looking at, from my perspective, no?
Yeah, that's true. And like the official chain is just the longest chain.
Right.
That is valid, right? And so if you modify your local chain, you would end up having like a different blockchain because you would have different hashes.
Right.
And the idea is that if you took the time to like go back and modify the blockchain, you would have to be proving work to catch up with the majority of the blockchain, and the majority of the blockchain, like statistically, it's going to work out that you don't have enough computational power to like catch up. Like if you have to go back and do work and then backfill like your chain to try and be the longest so that you can be the official chain, the real chains it's moving too. Like they haven't stopped, and so you won't ever be able to catch up and outrun the majority. The majority of the blockchain.
Unless you have 51% of the
Unless you have 51%, yeah, sure. That is worth pointing out. Yes, in the back.
So, is the idea over time each of the nodes will hold all of this? I know right now it's only the ECB is set, but over time transactions grow exponentially.
Yeah, that's true. So every node, like every full node, holds the entire data set. And so, you can imagine that this is problematic and kind of scary, right? Like, because the, Amazon's biggest instance has 244 gigabytes of memory. We're at like 30 today. Oh, like we're still in the young days of Bitcoin. Like, Bitcoin's probably going to be a thing 10 years from now. And it's also worth pointing out that these blocks, there is a maximum size to these blocks, and that size is 1 megabyte. And so because the block contains transactions, you can kind of work backwards from that to arrive at like this like maximum transaction throughput for the blockchain. So like blocks get created, like, and this is by design, blocks get created just about every 10 minutes. And so if a block can only contain 1 megabyte of data, you know, then you can look at like the average transaction size to kind of reason about how many transactions you can do in that 10 minutes. But now there is some experimental work going on to increase the size of a block. Gavin Andreessen, who is one of the primary developers of like he's on the Bitcoin Foundation, and he's basically like I think his title is like chief scientist for the Bitcoin Foundation. But he's been thinking a lot, and he's been writing a lot about what it would look like to have, say, like a 20 megabyte block size, or even larger. So there's a lot of work going on right now to kind of increase the block size so that we can have a higher transaction throughput. But there's all sorts of like really technical like reasons why that's kind of scary. And we'll cover this more later, but like there's this whole notion of BIPs, a Bitcoin Improvement Proposal. And so these are kind of how new ideas get discussed in the Bitcoin space. Yeah. Okay, so I have a slide for coin, like how coins are created. We'll get there. What was in the Genesis block? I think there's some interesting trivia there, and I don't know it off the top of my head, but I think Satoshi put. Okay, so the creator of Bitcoin, and just because this is introductory to Bitcoin, we have to talk about this. The creator of Bitcoin, his name is, or actually, I'm sorry, his or her name, or the group of people, their name is Satoshi Nakamoto. And they invented Bitcoin, and then in like 2011 or something, like they just disappeared, and we don't know who they are. So this technology that we're all excited about, that like we're all here today for, like we don't know who invented it, which is really weird because most of the time, like you know, like especially in software, you know, people like when you have a great idea, it usually takes like a company or like a group of people or one person to be like shoving it down everybody's throat, like use Ruby on Rails, use Ruby on Rails. But like this idea is so good that like the person who made it doesn't even like they don't even care, like they just kind of put it out there and like we're all excited about it. So I mean that's crazy. What are we even doing? This is wild. So okay, so back to the question, what was in the Genesis block? I think he I want to say like he hashed a newspaper article. Like it was when the fight. Did somebody know?
Yeah, it was a headline from the London Times. It was the Chancellor, who's the British equivalent of the Treasury Minister or Finance Minister, and he was bailing out the British banks for a second time. And the headline says Chancellor on the brink of second bailout for banks. So Satoshi put that and passed the message across the transaction or the first Genesis.
Right.
Go to bitcoinstrings.com and block0001.txt will tell you exactly what it is.
Okay, bitcoinstrings.com. You can find the answer there. But I think it's some pretty cool like weird trivia. Like he hashed a newspaper article that talked about the banks failing, and that was like the first piece of data into the blockchain.
So we have we put up a subreddit called Blockchain U. We'll put a couple links in there to the Genesis block for you.
Great.
I think just that also serves as a proof of existence, right? It's a real happy to use app on the blockchain.
Yeah, absolutely. Proof of existence, which is also a really neat tool to check out. There's a website called Proof of Existence, and you can hash data and put it into the blockchain. I don't know, it's weird. That's super high level. But hey, this is intro. We can talk about all this stuff and not really explain it. Okay, so what is a blockchain? I'm sure. Have you guys heard about this? Does this look familiar? These are names that are popular right now. Ethereum is a blockchain. Dogecoin is a blockchain. Dogecoin is just like a fork of Bitcoin. Like a lot of these projects, like if you look at them, like Litecoin or stuff like that, like and people have all these weird coins. Like they take Bitcoin and they literally like they fork it on GitHub and they make the changes that they want and they kind of start their own process. Ripple and Stellar. Have you guys heard of Ripple? Yeah. So Stellar it's the same thing. Like they literally took the Ripple source code one day and then forked it, and then there's like this commit in the GitHub history where they literally just renamed everything from Ripple to Stellar, and then they started on. So yeah.
I mean, it's still a blockchain. It's just a different blockchain, right? It's not.
Well, not really. So, okay, so let's talk about what is a blockchain, and this is like my definition, and I think it's like a reasonable. I don't know. You guys can nitpick it if you want, but a blockchain to me is like you have to have blocks and they have to be chained together, and then also what makes like a blockchain kind of like unique is the way that it achieves consensus. So in Bitcoin it's proof of work and it's mining. With Ripple and Stellar, which I pointed out are not blockchains, they have their own consensus model. So Paxos, how many people here have heard of Paxos? One, two, a few, okay. Raft is like kind of a new version of Paxos. But these are all, like, so Paxos Paxos is this algorithm for distributed consensus. And it was created by this guy named Leslie Lamport, who works at Microsoft Research, and it was created like in the, I want to say 70s or 80s. Anyways, there's been like decades of research into distributed consensus, but mostly in the context of database technology. So, we've all heard of like, you know, Mongo, and we've heard of Hortonworks. What's their the elephant? Somebody help me out. Hadoop. We've heard of Hadoop. You might have heard of etcd. Like there's all these like really crazy, or even like Berkeley DB, like some classics. Like there's all these database technologies that have been, you know, they've been developed for years, and they've all been trying to figure out this problem of like how do we have multiple like independent machines to like how do we take a database and instead of having it just on one machine, which is like hard to scale and is a single point of failure, how do we take this database and how do we distribute it across many machines so that we can partition our data so that we can have high availability, so we can eliminate single points of failure? Like, how can we do this? And so the academic community has just been spending a lot of time working on these consensus algorithms. And they're very, very hard. And there's so many weird edge cases, and like the network is always failing. And basically what academia has kind of like honed in on is like there's this problem called the Byzantine generals problem. And at a high level, it's basically like in Byzantine times, like you had 3 generals who were wanting to attack a city, and the generals had to like communicate, and they had to decide whether they were going to attack or retreat. And the problem was that like each general didn't know, like because they were like they were separated from the other generals, like they couldn't see them face to face. They had to rely on messengers to deliver like the message to like attack or retreat. And then they began to question like, well, what happens if like the enemy like, you know, takes one of our messengers, and like, you know, like they could spread bad information like, oh, we should retreat, you know, or oh, we should attack, and so like there's this whole problem of like how like when you don't trust your messenger, how can you design a system so that you can know whether you should attack or retreat? And this is like the Byzantine generals problem. And so Paxos and Raft are all trying to solve that. Just so happens that Bitcoin also is trying to solve this, because like we have this problem of like, okay, we have computers all over the network, and we're trying to agree, basically like what we're trying to do is we're trying to create a block, and in this block we're going to put transactions in it, and we're all going to agree that these transactions are valid.